Short background, my name is Shmuel Fine. I'm a freelancer in the area of algorithmics, mainly computer vision, but speech recognition and other things as well. I'm coming from both mathematical and programming background, and most of my programming is C, C++, GPU, stuff like that. Recently, me and my friend, we tried to take juniors to help us as a background, give us a back of programming to our algorithmic projects, since we want to do more mathematics, and since it's a good way to give real capacities to junior programmers. So we thought how to do that. One of my problems is that I love to talk and I love to explain things in a very step-by-step way that people sometimes get insulted that I teach them the things that they already know. They say, I'm not that dumb. Don't tell me that. So I don't know where to start because I can't say it, they'll be offended, and I can't not to say it because I want to be sure that they are aware of it. Now the area of algorithmics in general, is something that I have a very special requirements for those that give me a back. Before I show how I teach and what I do, there is a requirement that they will not be afraid to dig into anything. There is the OpenCV library, for example, which gives you a lot of functionality in computer vision, and it's C++. It has a C++ interface. It's written in C++. But when something doesn't work, I expect the programmer to compile it himself and to dig in, and not being afraid from some vectorization or compiler optimization, I don't know what. And if it's release time debugging, I want him to be aware that he can look at the EAX register to see the return value of a function if he needs to. So it can dig even to the level that I don't want them to be afraid of assembly and stuff like that. Also, I have real usage of the C language. And it's true that everything you can do in C, you can do in C++, and it's as efficient and so and so. But real example, OpenCL. OpenCL is a language for programming GPU, graphic cards. And OpenCL has evolved from C syntax to C++ syntax. The first OpenCL C++ syntax appeared at the specification 2.0. But NVIDIA, in all of their graphic cards and drivers, do not support this specification. That's because I think NVIDIA wants to promote their GPU languages like CUDA and utilities they do, which they do great, actually. They master the machine learning and artificial intelligence market. But OpenCL is a language which is very friendly. It's unlike OpenGL, which is older and has more cumbersome syntax. OpenCL has a really friendly syntax relatively for people that come just to compute something, just to try something, to run it fast. And it's cross-platform. There are many Qualcomm chips, there are many smartphones that support unofficially OpenCL, some officially support OpenCL. So when I was writing algorithms in computer vision that should be cross-platform, we were using OpenCL because that's what the company I was working at decided. And I've written a lot of C code. I want a person to be able to dig into C code and to write good designs in C code. Okay, so with this preamble, the way to go that I've decided is to create first C and C++ courses for newbies, and ask my the people that I do mentoring to, before we get to real projects, you'll help me with my courses. So I have 2 courses on Udemy of the C language. And I asked them to write summaries, to do the exercises with the Google test that follow them and check that the exercise was good, and so on. So now the rest of time, I'll show you the approach of the C courses, which is targeted towards newbies that are from the Z generation and passionless, and as Amir said, we want them to love C. So I really don't want to develop the whole full skill set. I just need them to know how to do things simple and right, and not most efficiently. I don't care about unique PTRs. I'm sorry, just shared PTR is okay. because I want, if they have a performance issue, they'll use a profiler and they should figure out the solution for themselves. Okay, so now, okay, this is irrelevant, you know it better than I. Okay. So when I thought where to start, I thought I want them to have the ability to fearlessly dig till the iron, till the assembly. So I begin with electrical engineering. What's wrong with electrical engineering? I mean, you can do really good stuff with electrical engineering. You can build circuits that solve differential equations. You can do many things, and they do it much faster. I mean, the minute you put the voltage in, you get the voltage out of the answer. The problem is that you have a circuit per problem, and you want something that will be able to be programmable after it is built. So it's complex. And now we have the context that we have a machine, which is a general purpose machine. It gets numbers as input, it gets instruction, and it outputs numbers. Now the twist is that the instructions are also numbers. It's a digital computing, meaning it speaks only numbers language. And then I come to the conclusion that we need to represent somehow numbers. How do we represent numbers? So that's a good place to talk about the punch cards and the punch films, because it's history, and it's a good thing to know. They appreciate their programming environment after that. So here's the place I speak about binary counting, get into the binary calculation, about bits, bytes, and I define a variable as a pretty name for a chunk of memory. I tell them, you actually know what a bit is, you know what a byte is. I know you can count binary. We open the memory window and we look inside. It's hexadecimal, it's also a good thing to know. So you actually know how to handle the raw memory. But since we have pretty names for it, we call it a variable, which is just a chunk of memory. Now I have a chunk of memory. I continue. Oh, I'm sorry. This is the way I explain binary counting. I tell them a story about a prodigy chicken. And the farmer asked the chicken, tell me, chicken, my daughter has a birthday, I need 10 eggs. And the chicken says, yeah, John, right, I'm going to get. And the chicken brings 4 eggs. I'm sorry, 5, because she counts, she has only 4 fingers, so it's 1, 2, 3, 10, right? 1, 2, 3, 4, 10. I'm sorry. So she brings 5. And then they come together and they come to the conclusion that the chicken is just brilliant, and binary is just cow counting, because cows has only 2 fingers. So it makes things much more appealing than Boolean logic. Okay. So now I have to develop the concept of assembly. So actually it's historically true that, each large computer had its own numbering of commands. And actually at the first time they had the same, each machine had its own assembly. So we came to higher language, we came to an assembly which is more or less accepted or supported, which is the 8086, and we had the B language, which is the Bell Labs. And then I teach them the first lesson. Ken and Richie wrote the C language, even though they had the B language, which means that even Ken and Richie didn't get right the first time. So programmers never get the things work right in the first time. It's an important thing to do. Okay. Now that we are familiar with the history of the language, we are familiar with the building blocks of the memory, more or less we understand this machine, that computer, what it came to solve. Well, how do I start teaching? My approach is very, very, very bottom-up. I want to deliver some intuition about things. So the first thing I start with is with nouns. Nouns is variables. Okay? So there's a pseudocode, and I just define variables through a story. There are 2 children. They are playing in the kindergarten. Now I want to ask the other child information and to store it in my computer. So I asked them, this friend age, how much bits does it need? And this, is he cool? It's only 1 bit, right? It's only true or false. So we start thinking about how much memory we need for different information. Sorry. Something didn't drop for me here. Ah, okay, it did work. I didn't notice. So we have the Boolean, which is the simplest. Is the we can represent it as 1 or 0, but we are working in chunks of bytes. So, okay, memory works in chunks of bytes. After Boolean, the most natural integer is the outside integer 8 type, because it's unsigned. It goes nicely from 0 to 235. Now that I know unsigned, I can talk about signed and then tell that, listen, it's not real numbers. It's just the way you encode. As long as you can read the bits that you've encoded, it's okay. You can do whatever you want. So then I can encode a character, which is a letter, and I can encode a floating point, which is totally different. Because there is this concept that I hide the implementation of the variable. And this is a good place as well to dig into the memory, to open the memory window, to pass the address, and to see the values that are inside. Yeah. So that's a good place to talk about variables, about the arithmetics, that integer arithmetics is not the same as float arithmetics, and so on and so on. And the typing. Okay. Now, this is an arguable point, because I can continue the bottom-up approach in 100% and avoid printf and scanf till I get functions, and use the debugger instead. Okay, but interacting with the computer is nice, and so printf and scanf it's the place I introduce them. Okay. Now we have variables, we know how to operate with them, we can do lots of stuff, but conditional flow. How to make a conditional flow? The answer is we have jump. So I introduce the if-else. We go into the assembly. There's an assembly window in Visual Studio. There's an assembly window in every good IDE. So we go to the assembly and we look how the condition is checked, how the compare is done, how the jump not equal is done. So they have a feeling that branching is not many different syntaxes. It's many things to maneuver the more or less same jump. For condition construction, I tell them a story that Jennifer is thinking if she should marry him. And she constructs a condition. And this condition has several problems. The first problem is that AND beats an OR. Okay? But so has I income can beat all of the rest of the arguments here. So it's a wrong thing to do. And actually the AND and OR are not supported in the C syntax. So we developed the appropriate syntax and put the brackets on and learn everything we have to say about compound condition construction and operations. Okay, so the next thing is if that instead of branching forward, it jumps backward, which is a loop. Okay, I'm starting with a while loop, and I'm going to the, because it's the simplest to show in assembly, and then the for loop and so on and so on. So each loop will show things that apply. Because I think that telling stories is a great way to attract attention. I've seen that even there's one author of children books that I very like, and one technique he uses is that he never ends the story with the moral that you learn from it. And now, children, we all learned that it's very important to be generous. No, it's not like that. it's like the character faces some difficulty, and then his friend tells him, like, listen, Yaakov, I think that you should give up. Or listen, Yaakov, I see that it's very important to you. So when you tell the moral as part of the story, it comes out clear. It comes out very nicely to the child, because it's not like, I'm now telling you how to live. It's part of the story. And here too, when people hear a story, it's the more you can push into the story, the better. They just have your attention. That's my approach. I like doing imitations. Not of only Russians and Americans, also French people. Sometimes they suffer from me. But with the loop, so we tell about some husband that his wife sent him to buy something late at night, and it iterates over stores to find the right store. Okay. Now we have loops. We can do recurrent tasks. We can handle large masses of data. Large masses of data, from my point of view, begins with one-dimensional array. And it is also a practical thing that two-dimensional array are implemented as one-dimensional array, as a one chunk of memory. And it has practical implications. For example, in this OpenCL development I couldn't pass two-dimensional array. I had only C-style movement from the CPU to the GPU. So, and it was image processing, so I had many of those two-dimensional arrays. So it's again a good point to gain intuition about how we do tricks to represent more complicated stuff. I asked them how to represent this index from one dimension to two-dimensional and back and so forth. Okay. So we can write any flow. We have the conditional flow, we have the recurrent flow, we have arrays, we have large amounts of data. No dynamic allocation yet, but the problem is order. We just stuff it all in the main function, right? Order is a big issue. Order is a big issue. Before each topic, I try to give them a sense of what's wrong. So in this part, I just tell them a story about a family that came into the hotel, and we are writing the program for the hotel clerk. So they're looking for a free room, and he should check if the free room was cleaned already or after it was dismissed by the previous guest and so on. And stuffing only part of it into the main function gives a good hunch why we should separate and do order. Even the punchline is that the prices change before holidays. And then I tell them that we need to go through the code and change the prices, and not to be confused when it's a price and when it's a room number, which is very important. Okay, so huge sticky, main block. So first thing to do is to replace the numeric value with defines or enums. Okay, now we can change prices. Second thing to do is, if we know defines, we can do macros. Okay. If we got to defines, we can do macros, which is very exciting. It's the first time we define an action by ourselves. Yeah, macros are alive. So when we speak about macros, it's a good thing to introduce the syntax. There is this continue to the next line syntax and more syntaxes. Yeah. And what's wrong with macros? We are not satisfied. What's wrong with macros? Hazards. We go through macro hazards, the brackets that if they are not placed, the pre-compiler can get it wrong and the compiler won't shout because... So it has a lot of hazards. Now, after it hurts them and they do some exercise like what's wrong with this macro and so on, we get to know the functions, which is the holy grail of C. Functions. Now we can speak about functions. What do we have about functions? We have by value reference, by value parameters. Okay, we can now explain it's a temporary variable. It passes to and we have limitations. We can change a variable. We can pass an array, and we don't know how to do dynamic allocation. The answer for those three questions is pointers, and dynamic allocation is also part of pointers. So now we can talk about pointers and memory. We can demonstrate pointers because it's not the first time we're going into the memory window. We've been there before. So we can point at existed variables before we point at something which is dynamically allocated. And arrays, when now we know memory blocks, we've worked with them, we've seen them, so now dynamic allocation is much simpler. Okay. Actually, yeah. Relations between pointers and arrays, yes, this size of trig that we lose the size of when we pass to a function and so on. It's a good place to talk about. And dynamic allocation. When we get to dynamic allocation, what I do in my Udemy course is that I scare them. I tell them what memory types we have. We have the hard disk, we have the RAM, and we have the registers. And it's important to understand because as a programmer you should understand what resources you have. So we get to know the memory, and then I tell them, no, you don't have to worry about it, it's virtual. You have virtual memory, so your blocks are very nice. But if the computer does not have enough resources, you should know it uses a swap file. And we can talk about swap file now. Okay, so we have now a general idea of what's registers, what's memory, what are the consequences of using too much memory. And now I have them knowing pointers, I have them knowing memory, they have this dynamic allocation skill. So that's the time to talk about text. Text in C, actually in general in algorithmics, it's only ASCII. All the folks that do Unicode are doing it in high-level languages. They handle it with more sophisticated tools. So there is no reason to talk about it in a C course. Okay, and the final note of the C part, I don't think we have time for the C++ part, but the final note for the C part is that a new mother comes with a newborn baby home and she wants to write lots of functions. Is he hungry? Is he tired? Is he sick? And so on. And each time she passes the amount of calories, his weight, his mood, did he slept today, and so forth. You know, all those considerations you should take. And it's just a big amount of variables that pass to each and every function. We don't want to write them each time, so we get to structures. We get to structures. Before we get to structures, her husband suggests to just allocate one big buffer of characters and to do mem copy to the buffer and from the buffer, and this way you can pass the whole block to the function. That's a good husband's advice. And actually that's something I did in the sort of a example from the OpenCL code where I had to pass a camera model and I didn't have the opportunity to pass it as a structure. It wasn't supported. So I had to do it this way, just passing a big block of memory and going to the right pointed, place in it. Okay, so C++, you can guess how will I continue it. The main idea is that C and each step in C has its practical implications, has something that they should not be afraid of, and it's something that they can meet. And I want them to try to cope things without the advanced tools at each step to make them feel the pain before they get the more advanced. And if I cover less ground, it's okay, because I hope that they will be able to dig in when they should. Okay, that's all for my presentation. Now let's. I have to show the picture, right? Okay.
A question: how long is the course?
It's very difficult to measure frontal courses by Udemy courses. I have 2 Udemy courses. I have 2 Udemy courses. And the first is, I think, 3.5 hours long, and the second one is yes, 5 or 6 hours. I didn't check.
Do you get statistics from Udemy on how long people take that? I mean, they break it. They do not do probably 3 hours in sequence.
I'll tell you the truth. Since my main public is my practitioners, so as long as Udemy, I have nice rating and I have more than 4,500 students there in the first course. The second was just released. By the way, the first course is for free. The second one is paid, but just email me. I'm the plumber of algoplum.com, and you'll get it for free. You and your students. So I'm counting on the abroad people to buy it. Okay, so I have quite a good rating. I think above 4 out of 5. So it's reasonable. Okay. Thank you.